And then will follow Mirek, OK2 Alpha Queen. He will have a presentation about the application of the small offset dishes for EME microwave traffic. Then we have a coffee break. Will follow Paul W1 Glow Hotel Zulu with the design of optimizing Cassegrain antenna systems. Follow up SM6 Foxtrot Hotel Zulu with the presentation about the matching feed in the dish. And before the lunch, I have a presentation about the 24 GHz portable EME. The program of that is stick in front of the door so that if you will be passing the door so that you can see that. Then we have a lunch, and after the lunch we will have a group photo. I would like to ask you to be front of the hotel exactly at 1 hour 15 minutes. 1 hour 15 minutes. I would like to have everybody on the picture. So 1:15. This is from our program. Another thing is that every part of this lecture will be held by our colleagues. The first part of the lectures will be moderated by Al, Kilo 2 United Yankee Hotel. And second part, up to the lunch, will be moderated by Jan, GM3 Sierra Echo Kilo. So those guys will guide you through this lecture until the lunch. I would like to ask if you have any question about this, and if you want to extend something in this. Nothing. That's perfect. So it looks that we made a good job. Guys, thank you very much again. You are coming. As I say, it was not easy. I know that the time was not tough only for us and also for you, because we spent 2 years under the COVID restrictions and everything about. We were preparing this conference for the right time in 2020, but in 2020 it was completely closed the country here for the traveling and everything. We were expecting to have it in 2021, so we start again to prepare everything. I have to say the big thanks to Franta, K1 Charlie Alpha, who was preparing your trips and everything about the trips for our ladies in Kutná Hora, Praha, Plzeň, and all those trips were under the Franta responsible, and he made a big job. Franta, thanks very much. Also, in this tough time, we lost a couple of our friends. As you know, not only COVID, but the biggest, I cannot to say the problem, but the biggest issue is our is the edge. And people are passing away. So please stand up for 1 minute. Okay, thank you. We have now prepared a presentation of Láďa, OK1 Delta Alpha Kilo, about the EME history in Czech Republic, Czechoslovakia, from really the beginning of the EME in Czech. And I would like also ask Al, K2UIH, if he can join us here on the stage and start to moderate our conference. Al, very good morning. Very good morning. Thank you very much. It's yours.
Thank you. We have a problem pronouncing, so when we say butcher, close it. Zednik's name, so
you hear me? So a bit tough. Just on één kant.
Mag toch? Ik ben niet stoer.
Okay, thank you. Well, so we thought, I think, about how to present what happened in the past. And actually, we concluded that some small tale looking for the history sometimes is quite good to remember what happened, and also some consequences which were not, say, accepted 20 years or 30 years before. And looking back, quite interesting, some things which were in fact would be underlined at the time, so we could be much better or succeed when we did not. So I will not use the left right, okay. So how it started in OKR, it was the time when we were together, Czechoslovakia, and divided in 93 later on. So in the 60s and 70s, say, in the world, the EME activity grown up, and of course we also looked on that, and probably one of the first to hear something where the moon was Ivo, at the time 1964, OK to WCG, later BCG, and well known this as a Z6AXT from South Africa. Unfortunately, he closed all the activity in 2017, as you know. He received MS signals from, at the time, KPZP, pieces from Puerto Rico in 5.9, as we remember that, on only 7-element diagram. So, after that, also in OK community, HFQHF, we were looking for how to join that activity, at least to receive, try to transmit as well. A lot of discussion where, and 70 centimeters was chosen at the time as a good band, which can be realizable. We should remember that it was in the time that the iron curtain here. We have nothing, in fact, looking behind what could be that, and what would gain somewhere and get as a present. The main problem at the time was antenna, of course, and tracking the moon. Today it looks like quite easy what we are talking about, but at the time it was a big challenge for us. We have already at the time quite reasonable, quite good equipment at the time. But what was the trouble? There were no computers, nothing about how to track the moon. Of course, astronomers, radio astronomers were using polar mount and so on. But back when Carol OK1P and W at the time was able, in his job, to calculate the things and so on. So he got, for example, this one graph, position of the moon this one is right one. Oh, yes. From the zenith, moving in the time, our time, and so on, so we can find elevation and azimuths for moving the dish almost, of course, manually, and so on. Nothing easy. Someone should try today to comparison how it was and what it needs to about. So how it continued? The talks how and when, in fact, continued some time, but we were lucky that we got some possibilities in Onzeo, near the Prague, where 7.5 dish were around from the Second World War, was used for measuring sun noise. And sun noise, of course, is measured during the day. So there was chance to get it borrowed for night, for moon. But it was not as easy as we supposed. On the other side, I found Docent Walíček as the chief of the department, and after some time we get some good relations, in fact, and understanding for the stupidity I can radio, yes. It could be tolerated for some trials. So, VA6 sled probably not down. We got chance for November 1975. They announced a test in the time when moon was in Europe during the night time. So we got everything together. How it looks like it's the other way. This is the dish I'm talking about, so you know. That was just November 1975, how it looked like at the time. So it's some almost 50 years back. And most important is here, you can see this is log periodic peak shape, log periodic antenna for the high bands, and there is log periodic for the low bands, up to down to 100 or even maybe less megahertz. Pardon, microphone to the holder. So backwards, everything prepared on the day, as you can see here. Good group, quite a lot of people were interested how it could work and so on. What was on the other side, 45 meter dish, 45 dB gain, kilowatt, we allow just 1 dB LNA focus, so we suppose that should not be principally no trouble. Trouble could be on our side that we have only about some 200 plus watt power. Well, everything looked quite good, but there was one trouble that we were at the time. We were not allowed to change anything on the equipment. So just disconnect the cable to the equipment from the feed, which was connected to the sun noise measuring equipment, and used it for our test during the night. But that probably was the trouble, but we did not realize that at the time, so we were still full enthusiasm and looking for how to receive and transmit. It was very good. We received over 10 dB, VA6 LET almost all the time. So we tried to transmit, no response. All the time, no response. So, in fact, we were really disappointed with the result and looking what could be the trouble on our side and so on. But later, we sent a report about receiving HSVL, and surprising, sometime after several weeks, we got response from VA6 that, as you can see here, that we were found on the magnetic tape as K1, KFO, just one dot missing. You know, the drops on 76 are very short and almost not audible. So they probably said, okay, stupidity, cannot be OK station, so must be K1, KFO. So that was something satisfaction for us that it was not so bad probably. So we looked how to improve the station as VA6 LET announced repetition, as you can see here, repetition in May 1976. We finished new power, new 2 times gains and power amplifier for 70, giving more than 500 watt maybe we were in peak up to 700-800, so quite good job. And most important, I agreed with Kutzenweiler for the night, he will close his eyes and will tolerate that we remove the original periodic feeder, and you can see here, and this is new package cross dipoles cycle polarization feed 470. I forgot to mention that the VA6 LED used at the time, probably common for radio astronomers, cycle polarization, but we got no information, or maybe we forgot that there is some sense left, and so on. So we changed this package, small one here, cross dipoles, with relay to switch polarization. So we were able to look on VA6 LED signals on right-hand polarization and also at left-hand polarization. Quite interesting that was. So you can see here removed of periodic feed. Most important was that this way was during the day, so we were allowed to use it even for some noise measurements. So relations established, we were in fact agreed that we are not some stupid guys trying something, but that it's something with sense. For technicians, there are some details. The focus on 0.23, so the dipoles was the only solution. I'm not sure how close we were to the real feed point, but it was quite good. Sun noise was 8.5 dB, and interesting maybe is that we were in apogee, so the maximum distance of the moon, but everything was okay. You can see this arrangement here. What can be interesting is here on the receiving side, MWEC, that is Second World War tank receiver. In fact, somebody knows that, or probably know that tubes like W12P2000, so on, well-known things. This was choice because we used it for EME a lot of years after. There was benefit move changeable from 0.3 to 6 kilohertz. So 300 hertz is quite good bandwidth for the time. We used about 700 during the test. So what else may be interesting for somebody who is concerned about the techniques? Quite low elevation during the time and so on. So we got two cursors, we repeated cursor at 11 and an hour later, one more again. One thing is quite interesting what you can, sorry for moving the microphone. To compare today, if we use, for example, VKCUM software, so you can calculate some 16 dB of noise, sun noise, we got only 8.5 dB. But if I looked on VKCUM, backwards, engineered the situation, it was quite reasonable to all the parameters I presented 2 slides back. So that's almost all. After that, after the enthusiasms evaporated and so on, so will become the question how to continue reasonable, ordinary, and so on. Should mention that at the time already some arrangements for the sketch was not as easy as today. No internet, we have nothing, but just post, and all was great. Started the newsletter. The last page was full of sketches pre-arranged. So if something has to be changed, we send a letter and waiting for a response, and so 2 weeks are gone, and so on. Nothing easy. But it worked. What continued later? We, as Oka and Sky, were not active at the time, as we were looking for the dish and especially for the place where and how to arrange the dish. But in Slovakia, Macedonia, Jano OKCCTP looked on situation and was very quick and created huge, really huge system, 16 at the time with something extra, 21 element system. What is for me interesting was welded from steel. So this is, by my understanding, not a good surface for the antenna, especially as regards the attenuation on the surface. But it worked very well, based on some information from France, from well-known 5STS team. He got everything together and started on February 23rd. Immediately, first day, 7 QSR and continued with full enthusiasm and completely during the first months. At the time was fantastic, 27 QSRs, 4 continents and so on, continued. 138 QSRs during 1 year and so on, completed local continents and so on. Was very active till 1982. After that he got some troubles with regards political situation local, so he lost the license and so on. So some such things happened at the time. As regards the other OK1 MBS, now last year's OK1 MS, in 1980 already, so that means 40 years ago, on 21st November, my first Oka QSR, also 2 meter. You can see this antenna, H-time, Diodman BV, Jano, this one is artificial photo effect, huge system really. OK1 MS completed up to over 1,000 editions, so still active on 2 meter.
CW initials. CW initials. It is not a digital, it's a CW.
CW, I forgot, yes. All was CW. Not mixed, what is normal today or digi. Sorry, forgot to underline. So as regards our sky here, so we started in that strange way. We got 4 meter dish from old radio relay links. It was arranged for 2 gigahertz, Rafael, DDR, production and so on, but we were happy to have at least something. So another opportunity was SK2 GJ, something like DA6 LED, test for ham radios on EME. So on 29th November, we arranged in that strange way everything, and trying the equipment was in the car, and so on. Some details later, you can see that I don't go to details too much. We got QSL cards from that, everything was okay. Surprisingly, even the turning the dish was quite acceptable regardless the height and so on. Well, some details you can see how the dish was arranged in fact for the time waiting for SK2 GJ. You can see, you can see the nuts for elevation and azimuth was stored over there in the dark. These two lines were for azimuth and so on. Quite pioneering times for looking for that today. After that, in 1984, you can see how it looks like in our stand there in January. This is arrangement for 13 centimeters. I put this picture there. It was really hard work for some tens of watt only on 13. 4 times here combined to C39. We used the DDR production HT323 tubes, which were in fact equivalent or should be equivalent. There is power amplifier 4 times, and what you see there, the oil cooling as it was in principle almost over for heating, not for producing RF power. But with that arrangement we were able to balance around 100 watts, what was great power for the time. But trouble was in high view of the cavities with tubes, so everything moved in time and so on. So just to have a picture about. You can see the cooling system with oil. First we used air and after that oil, because in later time there was temperatures below 0. You can see how it looks like, the combiners and so on. Unfortunately, in 2002, after terrible floods, everything was covered by not only dust but mud and so on, chemicals inside and so this was in fact moved out of the shelters over there. The shelters was from wooden, so they damaged totally in fact in 2 days. Surprisingly, this equipment were there, so then I just second day disappeared. Probably not for another invader, but somebody for steel expert. So later on, you can see polar mount used for many years. Here is 3 centimeters. Already at the time we used sacral polarization feed, so Tunda prepared special homemade, in fact, waveguides which doubled for square septum polarizer in there, transition to tubular feed. Quite interesting, but we realized later on that we talked about warm grid or necessary CP, but almost station state linear polarization, so in fact we prepared as well linear polarization, and almost linear was used for next times. So you can see how it looks like. Behind the dish is TWT, is power supply and transverter, everything except the TVT was homemade and so on. You can see this septum polarizer and 2 outputs to the double waveguide switch and so on. In 1993, first 6 centimeters compressor in Oka. And using CP already in 1983, but that was, I think, only 1 or 2 USOs with CP or others with linear polarization. 94 continuous 6 centimeter or 9 ERC or now. What you can see here, that's similar situation to 3 centimeters. Tonda created special 3-way waveguide switch, septum polarizer, feed, and so on, like common, but that's a special arrangement which was used to be able to insert low noise amplifier at the feed point to minimize any additional losses. But quite good, and surprisingly the dish, 4 meter dish, which was produced for 2 gigahertz only, was still quite good or acceptable on 6 centimeter. Another picture. Back on the dish, you can see polar mount here. The power supply for the translator and power supply for TVT. It was inside the box. Interesting maybe for looking for way that mics was Schottky diode RX mics. Step carrier was used in the multipliers, in transmitter chains and so on, and EVT rate 20 watts. Quite more modern equipment at the time for us, at least. Something interesting was on that QSOS SM4DHN. We used CP as agreed, standard, but we got report only OM, just recognizable, so we tried to ignore that that's not possible, and he was sure that he is right in polarization, probably about the reflection from the dish moves the sense. So we say, okay, wait some time, and we standardly rearrange everything in 1 hour, rearrange everything and change the polarization to the opposite, and result was immediately 549,519. So that was some trouble with the secular polarization at the origin. And what followed that? Already 2001 year, we got really extra business. We gained this one dish 4.5 meter and RL5 meteorological radar working on 3 and 8 gigahertz. It should go to the scrap and it got a chance to grab it. So you can see in general how we prepare the things for a really big dish. Nothing like 1 cubic concrete, but it was really big deal. You can see the old dish over there close to. So how it looked like? Steel base preparing, some concrete base and so on, as you can see, and some small, if I can go. This is the system. How I can get
So it's doesn't work.
before.
It's work.
You want to try to
video.
film video.
Ah, okay. Go back.
No, sorry.
Go back. Cannot open.
Cannot open. I don't know how.
Because it's not in presentation, just file.
Are they all in the same package? I have it in the same package.
I got it. Myśmy jeszcze to wezmęczył.
Sorry, I apologize. I should try it.
Yeah, sorry.
Conference English should be better. I hope so. It's terrible. Someone to help it close to max.
Permiso de video.
No.
So you can see Tonda moving concrete to get flat base for the construction of the tower. Most of it was November and December 2001. Moving some wooden desks, and this is the steel base for the tower. You know, somebody once heard it, who knows? Yeah. Tunda mentioned that this base was used for design for 30 meters tall tower. But probably we were preparing for 47 gigahertz.
To můžu posunout, není problém.
No, to je ono, tohle. Cítku občas krtí. Dobrý, to je rozpoč. So you can see the installation of the base. Sometimes it was not easy to the holes each to other to get the screw through the holes. Sometimes hammer helps. You know, chain spanner was used to arrange the things as well. So almost prepared for concrete. Cleaning the dish also. How to fry some steel inside. Mixed with tummy. I thought it. So fire arrangement you can see almost finished. So it was all for December 2001. This time. Yeah, thank you. So this is the status you can see here. And afterwards, tower itself, by the crane was moved. Shelters, we get 2 shelters on this bottom, and you will see the upper one. Almost ready, April next year, 2002, joining everything and so on. And in fact, after the special interface here, you see, prepared for the pedestal of the dish, and dish is somewhere here. Moving the dish. Jestli se jako můžeš. Jo, tam je taky ještě. Jo, tady ještě. Tady stále.
To stejně nevím, jak jsme na tom s časem.
V pohodě ještě.
Jo, nevím.
Questa qui ti diventa in Italia.
Jak se to jmenuje, Láďo?
Pedestal, něco takového.
Jo.
Oh, really sorry for that. I should just. So you can see the interface is moving up at the top of the tower. If you can sometimes move it forward as a bit to save time. Dish prepared already to be moved afterwards. This is the pedestal, how to say, the holder of the dish itself. Some coffee break. Beautiful as well. So that's almost everything. Part of the tower needed to be removed for the whole pedestal during the travel came with some troubles how to get it up. Some cleaning as it was covered by the mud during the floods in September. So we can see, why not have a radio with something like professional situation. So if we can move that back to the present, okay, perfect. So next was moving the dish itself. Next video is placing finally the dish. You can see here, goes up, then extend it. Yeah, okay. It was quite a tough job even for the crane operator, as he as mentioned, never did something like that, especially not for a radio. It's okay one PCI over there in the dish to remove the ropes after settling the dish. The main trouble was the fast screw to get in the holes, then fasten the rest. Going down, I could not give you that photo. So we talked to him that, okay, we go for lunch. Wait a minute. So finalizing all the joints and so on. Maybe then if you can move it a bit forward, be so kind. Ah, yeah, okay, doctor. You can see all the things fastened together. Hand move, testing if everything is okay, if not damage something. I remove this so everything looked perfect really, and the main surprise was later on that really the mechanics or gears used in that meteorological radar we discovered are really perfect. The backslash almost zero is backslash in azimuth especially and also in elevation. So that's like a PR. Well, thanks. So that was on 21st July 2002, and we did not expect what would happen just close to the 10th EME conference in Prague. You can see this was some situation when we supposed all is passed. We can be happy, this one level of the water. But after that, another wave of water, mud and dust and everything inside chemicals, oil and so on came. We have no pictures from that because I got already no film in the photo, no digital, another photo. So that was really, as I call it, day after, in fact.
And as you can see, it's absolutely exactly 20 years ago, August 17.
Now this. So, Zenik is ještě ten after waterfall. A short video just to see how it looked like after. So if I ended in that way, almost everything was so deeply damaged that the repair was out of chance in fact. So you can see that's the wood shelters used for operation over there, right inside, just steel cabins, survive only. And this is operator table and place with equipment. Just no water, it was everything else. If it would be only water, so it should be better. And house was in the same situation. Yeah. But that's it took several months till the water was in fact. So that's all. So happened. there is a fact that for us that was more than 1 year break in all the activities and operation. But in 2003, you can see some special arrangements. We tested the focus and so on, and also we used on the pipettes special arrangement that we were able to move the choke on the tubular feed to test the things how it looks like, the dishes. We haven't any parameters or data about it, just that it was used for meteorological radar and 3 and 8 regards. But everything looked very good, so we were already at the time satisfied with all the things. But the break was quite long, so what further? In 2002, someone else also, OK to CA, made first 9 centimeter MQSO from OK. You can see his dish at the time, 3 centimeter 0.35. Everything in the feed point. Detail view here, 15 watt output. Well-known ATF 36077. Leader feed was used, not cycle like today. There is detail of the arrangement. 2003, we moved here in OK to 24 gigahertz. PEPA, OK1 UWA, arranged the things for 24 gigahertz in C-meter parabolic dish using special EWT amplifier. LNA, very good. He was talking about 1.35 dB, who knows, probably a question of measurement. But working. Trouble was that the TWTA it's a mistake with 70, but I don't know. He was giving 30 watt output. Trouble was that the TWTA amplifier was designed for satellite.
That's correct, Laja, because W5 was using 70 watt.
You're right, okay, sorry.
That's correct.
I have that view from that
Yeah.
position. That the TV 5-minute sessions, because the TVK was designed for satellite continuous service. If one switch it off for receiving something, after that should wait 5 minutes for heating the tube and so on, continuing transmission. So it was not easy. But Al was satisfied with that, as it was one of his first 24 gigahertz QSOs. However, there were some troubles with it, but after some trials, all the August they tried and without success. In fact, who knows what was the reason that not satisfied, but on 24 September, they succeeded with M report just on the edge effect with 24 gigahertz first in OK. So that was in fact all the bands we are using today, except of course the last situation about the higher bands. So, some remembering, in Prague in 2002, so as Zdeněk mentioned 20 years ago, we were in Oka, and must say that was already this situation for Czech part, so Czech Republic, not for the Slovak Republic, as we mostly divided in 1993. You can see just few stations were active on 2002, 7023. 2 meters, I'm not sure about the 10 I1BIX could say something more accurate about it. Microwave station till 2002 as well, 1, 2, 3. So it was really origin of EME in OK. Next year, what happened next year, you can see some overview. I think that not necessary for me to comment everything, so you can read it or how that continues up to 2022. Activity was raising up, as you can see also. This is important. 2003, we used secularization trials, but very quickly we recognize that almost everyone is using LP, so changing arrangement for our dish is not easy. That means the dish is hanging very slowly to the fixed position to the parking. So it takes half an hour, almost half an hour to change anything in the feed point and so on. So if the station was not using CP and going with LP, we should do such arrangements very hard and complicated, especially in time consuming. So we moved back to LP. In 2006, maybe someone remember DK or SB linear to circularization test, continuing further. Also Charlie G3WDG was involved very hard in that situation, even arrange the things to measure something, the difference and so on. You can see others continuing the development of the equipment and continuing here with DFC and OK1AQ with GAN amplifiers from 3 centimeters and so on. And Zenek is going for the 47 GHz trials, as was mentioned yesterday, or something another. You know what to comment to it. Guy with expeditions. Yeah. Actually, most of your countries and initials were done only thanks to these expeditions and expeditions of the others. What I would like to mention is this map of Australia, mainland, when VK7MO done something magnificent effect going through from Hobart in Tasmania, going through the mainland, through all these squares, and working on 3 centimeters and 24 gigahertz as well, with small dishes, 70 centimeters from 10 gigahertz and 1.1 meter with 24 gigahertz. So we were almost all the time active, and during the time from October 12 to 2018, during 60s, several expeditions, and we have done 125 squares in Australia and 25 squares on 24 gigahertz. So it was really something exceptional. How it looks like in the years. So you can see, as I mentioned here, 2002, and we are continuously growing, but question if we will be able to continue. How it looks on 26 centimeters during the time, so the similar curve. Probably you can see that the 23 centimeters is the best one. Band for EME. So they're quite easy to establish, and the dishes are not necessary to have something like several meters already, 2.4 and so on. Even 1 meter stretch dish are quite good to make a lot of QSO. When we move to digging, someone don't like digging, but of course on digging we can do QSOs on the much smaller equipment and lower powers and so on. What about microwave? You can see situation of microwave as well in years. 94 year, 95. This was conference. We were 4 stations active, nowadays 7, and so on. Of course, higher bands. We are still happy guys having license for 3.4 gigahertz, which probably will be lost in many countries for mobile services. 6 centimeters a bit stagnation. Probably the fact is that there are trouble with any trans equipment to get things and so on. 24 gigahertz is the same, but equipment can be collected somehow. So, some curves, as you can see, in the time from 76, I took that origin as what we make the first USO, EME USO in UK, up to nowadays. On microwave it looks like that. Not as many stations, but still really good growth from 2000 up to now. So what else so far? I think that we should continue. What else? Thank you for attention.
Great job. Now we have time for questions. So any questions on the OK1KR? I have a question. What's in your water here in this area here? Because I come from the States, and it's very hard to get more activity on EME and on particularly the microwave bands. And, I made charts up similar to yours, and I say, what's so special about OK? There's so many operators, and I think the water is flowing over to Poland, too, because I see there's quite a boost in SP stations on EME. And I really, this is, to me, I'm an educator, and I'm interested in seeing more people getting involved in microwaves, not just as an amateur radio operator, but in the future of our countries and the world. And it's a very difficult time to get, I'll use the word kids, interested in STEM. And I know Peter, G3LP, and after myself have talked about this. The situation's not much different in UK. So what is it? What is it that you're doing over here that's so successful?
It's hard to say from inside. The others must look for that. What is some different but be honest, if I can mention, I am a bit pessimistic that the growth probably will not continue as easy as it looked like from the camps, because the youth is not so enthusiastic in America like we were and still are. But on the other side, it depends on us how to involve others. Try something that really good and radio and joint.
Well, if you figure this out, and it'd be nice with something as simple as the water, so we could bring some of that all around the world. But this is a problem, and you're maybe not have the total solution, but you're doing things well. Wow. Can I ask you to sit down and keep track of the time for me?
Okay, I will just interrupt you because I would like to introduce Al. Because Al is very well known ham radio, active up to 10 gigs, and he has prepared for us a presentation about using the prime focus dish in offset application. So Al, please.
Okay, are you going to move the slides with me, or Yeah,
I have three of those slides.
okay, right. So this is a little different. I talked to groups locally on getting on EME and getting started, but virtually everyone here is on EME. But the majority of us are on 432 and that band 2 meters, which is I've operated too. It's a great band, but it seems like things are better as you go higher in frequency. And I won't spend a lot of time talking about that. But what I was going to talk about here is there are a lot of stations that have dishes they use on EME on 432 and more so today on 1296. And can you do anything with these dishes that were never designed for the higher bands? And so what I'm going to talk about is why would you want to do this? This is my dish, which has been up since, it's going to be 50 years next year. Went up in 73. And so why is this something you might want to do? And what are the problems in doing it? How to get started? Possible improvements in where we are in terms of performance. This is the objectives of the talk. And why do you want to do it? Well, the truth is you don't want to do it. That's the truth. If you have everything there and you get it done. But what happens is that when you look at putting together a system, it can take much less effort if you have a dish that's already up, it's mounted, the readouts are on it, the lines are to it. It's a lot easier time-wise to take a dish that's not designed to be operated at a higher band. Let's say you're on 1296 now and you like to go up to 13 centimeters, okay? You say, well, now, this dish was never intended to use on 13 centimeters. Well, it's very easy to take that dish and drop in a feed. A lot of the work you do when you go higher in frequency is you duplicate the tracking system. You've got to go through the mounting. So there's a large percentage that if you have the dish already up, here, pretty much independent of dish size, and can be 20% of the work. All this other stuff. Mounting and tracking these things. So if you have a dish in operation, you may only need to change the feed. The same cables can be used, and you just drop the equipment in. If you have a dish on 23 centimeters, my point here, it is very likely it can be used in the next higher band, 13 centimeters. And I think the story I have here is kind of interesting because I have this dish. It's a C-band dish. I'll show you the surface mesh is, it's not nowhere near where you would want to use on 3 centimeters. And I started off with this dish on 432 in 1973. It's almost 50 years. And then a few years later, we got on 1296. And then when the microwave weekends were added to the ARL contest, we started to say, well, can we make use of this system on 13 centimeters? I had used it on 13 centimeters, but not on a regular basis, and got good results. Even though the mesh is really large, it's basically a C-band dish from what I can see. And then K2 MMB, I don't know if he's here at the conference or not, he's still active. He wrote a piece about trying a 3.5 meter homebrew dish on 3 centimeters. And he had some success with it. It wasn't great, but he was able to make some contact. So that got me to thinking, could this dish that's not the greatest be used on 3 centimeters? So back in 2008, and this was without any real optimization, testing, we stuck a feed in, from my tropo system, basically, in this, and on 3 centimeters. This is back in 2008. I used to contest with K1JT. We as a group there, we used Joe's call, but it basically was operation from my place. So we all stuck my 3 centimeter tropo system in the feed, and we looked at the rising moon, and we were amazed because there were signals. We look at, oops, my fat fingers here. We did a little optimization. We basically looked at sun noise, and we immediately heard stations. You know, so the dish, we're using a TV camera. Moon comes up, and you point at that. We immediately heard stations, and we made 8 QSOs. And I point back then. This was the real stuff. It was on CW. We didn't have options back then. These were the stations I worked. Some of them you may remember. A number of I don't know if is anyone here at the conference from well, obviously Toronto's here. OK1CA with his great 3 centimeter signal. But a lot of the stations here are still active. F5JFW, of course, WA6PY, and G4NS. One of the problems, and I'm going to get to that, is that the beam width of a 28-foot dish, and let me put that's roughly 8 meters, for those of you who think in meters, it is about 2/10 of a degree. And all we did was, as was suggested before, what we did was track with the EME, with a TV camera. We turned the TV camera, marked a spot on the camera where the moon should be, or on the monitor, and use that. But the point here is that you can do things with the dishes at higher frequencies than you think you can, and it's worthwhile trying. We talk about, well, how well is it going to work? Will you be able to make QSOs? My feeling is that you try this, and then you just might get hooked and build a better dish and better equipment. That's what usually happens. But usually, when someone starts talking about going on these bands, they start making plans, and it's 2 or 3 years before, and I see this all the time, before they get on, even though they have equipment on the lower bands. And so what I'm suggesting is try it on the higher bands. This curve shows how you lose in gain, and there's a significant drop. You can lose easily 10 dB because of errors in the surface. There are really 3 basic problems using a dish at the higher frequencies than it's designed for. First of all is the gain loss due to the inaccuracies of the surface. And the curve over here shows you the RMS area. Now this gets very hard. You know, how do you figure the RMS? You know, it's not just the peak ripple. You can have a dish and have one error. You know, one half the dish be a quarter wavelength out of phase with the other half of the dish, and you're going to get 0 gain. Everything's going to cancel out. So it's tricky. I don't think you really know how bad the surface of your dish is, despite what this curve says, without just going out and doing the measurement. And usually that's not that hard to do. So in using my case as an example, at 3 centimeters, a 1/10 of an inch error is 6 dB a loss. And that is, of course, cutting the same as running not a 28-foot dish, but a 14-foot dish, or a 4-meter dish at the same frequencies. That's not too bad. You know, 4-meter dish works pretty well. If I'm giving up that just to get on 3 centimeters without having to build a full second system. The bottom line here, though, is that what you really need to do is do some measurements to know where you're at and what your possibilities are. The second area of problem is difficulty in pointing a big dish. And I hear a lot of people say, oh, I can't do that. I can't, you're never going to be able to point with the small beam width of, because of the size of the dish. And I've already mentioned that the 28-foot dish has around 2/10 of the beam width. This is, I'll admit, this is a very, very tight beam width, but somehow, especially with a TV camera when we first started this, and I have an automatic tracking system, and it tracks at 3 centimeters. Now, it's not one of those sit and forget. After a few hours of work, I'll go back and I'll recalibrate where the moon is exactly on the system using moon noise, and then let it go again. But it does work even with this system. I'm using a DRZ controller. K2TXB right now is doing the DRZ controller hardware and software. And I'm using USD absolute encoders just to give you a feel. The nice thing about the software that I use is that it corrects. In other words, the dish may move on either tower, and my dish rotates around the tower. And quite frankly, I have a chain here, and there's slop in that chain. So if the wind is blowing, I'll get some slop. But the nice thing about the tracking program is it's looking at where the dish is. And if the dish moves, it just corrects and brings it back. So I have a problem with QSB, but it doesn't mean I can't make a QSO. And I find that's a good compromise. And the biggest, or the third, for me, not for everybody, but in terms of the big problem is the increase in noise due to leakage in the reflector. And this is the size of the mesh on my dish. The mesh is roughly 3/4 of an inch. That's a little less than 2 centimeters in the long direction, and about 1/2 inch in the short dimension of the dish. So the high earth is a big problem because the signal spills through this mesh, and you can really see it when you take the dish. And I was talking about that earlier. If you're looking on the horizon, actually, there's an advantage, or near the horizon, because most of the spill is not hitting the earth. As you go up higher and higher, more of the spill through the dish is seeing the earth. So when you're at a high elevation, you're going to get poor performance than when you're a lower position with this type of thing. So one of the solutions is to put a better surface here. And there you see someone up on top of the dish putting a better surface on it. I tried this once and I wasn't happy with the results. And I concerned that the mesh I used, so I got a better mesh. But the second time I did this, I said, well, I'm going to use an offset dish for the surface. And I think most of everyone here knows how an offset dish works, but I'll just take a moment here. You have a regular dish, and with an offset dish, you just take a portion of that dish and illuminate it. And an offset dish, the focal point of the offset is exactly the same focal point if you had a whole dish. You're just eliminating part of the dish. And so I decided, in the system I presently have, is to use 1/3 of my dish surface. So I put a better mesh on the 1/3 of the dish surface, and I put it on the upper part. If you think about it, this is, where's my spill going? Where's my feed through? So I can use the upper part of it, and then I just move the pointing, not the position of the feed, but the pointing of the feed. I tilt it upward to cover the portion of the dish I want. And the feed points to the better surface. So I need a higher gain feed, obviously, because I don't want to illuminate the whole dish. I only want to illuminate part of the dish. And you need here, the equivalent is to go from a deep dish. This dish is about 0.42 in F over D. When I do this, this makes the equivalent F over D of something like an 8/10 dish to properly illuminate this portion of the dish. So I need a higher gain feed. I got to make a bigger feed to illuminate the portion of the dish that is being used. And this is another way of illustrating the same point here. This is where the finer meshes on the dish, and the smaller area of the dish means that I have a bigger beam width, not a lot, but rather than having 2/10 to worry about, I have 2/10 of a degree to point with, and that's a fact that if you start looking at the pointing, that the bigger dish proportionally isn't as bad as you think about it when you look at what happens area-wise. The feed point does not change. I made that point, but you need a sharper beam width to illuminate this versus the whole dish where the finer mesh is. And just for reference, and this is I made the slides available, is available, but this shows you what happens to the F over D of this is the reflector by itself. I'm right down here around 0.42. So as I said, I need someplace about a feed for 0.8 F over D dish to illuminate the offset portion of the dish that I'm using. And what I've been experimenting with actually KN0WS started making up these 3D printed feeds. So he's been printing up the 3D printed feeds. And these are showing you some examples of higher gain feeds designed to illuminate the dish. This is a 3 centimeter feed, and over here, these are both 3 centimeters, and this is a 6 centimeter feed to feed the dish at 6 centimeters. So this is just a set of ideas. The objective here is to take and get more activity on the higher bands and offer an idea to consider. You should move up the higher bands to get more activity up there, but you may want to plan it with you don't need to go to a bigger dish, but if you have a dish already, it's really easy just to take the feed out and put another system in. One of the things I don't think I discussed here in detail, but what I've been doing on the higher bands is I put the transverter, the amplifier, and the feed all together as one package. And that package moves up there. That makes it very easy to use the existing cables that I have. I don't have to worry about running a waveguide or feed. I just feed everything up to the IF, and both I transmit and receive, and I just drop that package in for each one of the microwave bands. And just in summary, I've showed how dishes can often be used on higher bands than originally designed intended. And as I said, all you need to do is basically change your feed package. And but it's not without loss. But you can stand a lot of loss of dish performance and still make QSOs. And the whole thing is you are QRV. You can live with the loss is what I'm trying to say here. And I showed how offset arrangements of feeding may be used to improve the performance or ease the problem of going to these higher bands. I'm still working on trying to come up with the optimum feed and the best arrangement for particularly 3 centimeters. Thank you.
Thank you very much for this very interesting presentation. Gentlemen, any question to Al? Yes, Manfred. Manfred, just a second, I give you microphone. It will be better.
Al, thank you very much for your presentation. Per mass, you lose 60 B using only the upper part of the dish. What do you think is an improvement that you can use the lower part as a shield against ground noise? Do you think that there is some improvement, that there is still the lower part of the dish shielding you, or not?
Well, there always is some extra, but the whole key is the feed. See, if you're only feeding the higher portion of the dish, then there's no energy or very little energy. If I skip back, okay. There's very little energy. There's no energy here to spill. There's no energy here to spill through
But from the
dish.
side lobes from the feed?
Probably. If the feed's well designed, you shouldn't have a problem really with, there always is some silos, but they're so far down. And it's what you're doing is you're integrating all the energy. And so if you have some side lobe that's here or off the back, the contribution of those side lobes usually are very, very small. Okay? And the advantage, there is an advantage, but the whole point here is that there's a lot of feed through here. So if there's a side lobe there, that will feed through the dish because the mesh of the dish is so big.
Second question, could you go back to your table? You show the F2D table. Most interesting is the lowest line, because if you have a dish with an F2D from 0.28, this is very, very hard to eliminate. Not on the right side, the lowest on the right side. Is it 2.8 is it? Yes. It is hard to eliminate it as a prime focus dish, but if you use only half of that, then you can use a feed of 0.4. This opens maybe for some people having very deep dishes the possibility to eliminate the dish perfect.
Depending on the size of the dish, that might make a lot of sense.
No. Okay.
Other question? Yes.
Thank you all. Interesting, stimulating ideas. Question, ever thought about filling the whole dish with aluminum foil?
Well, there are problems with winter snows and
Sure,
things
of
like
course.
that.
For one evening.
But that's what I started out. I actually covered the whole dish with screening, but I was concerned that the screening, the way the electrical contact between the screening was made, I didn't think I was getting the advantage of it. And then when winter came along, I decided to move the finer mesh. Now I've had this mesh up over the third and the top through winter, and hasn't been a big problem versus covering the whole dish. So I think there's advantages that way from the point of view of it's not so much wind loading as loading when the dish ice is up and with snow.
One night stand.
Well, I'm hoping this will be in place for another 50 years.
Okay, thank you very much for your presentation. Here I am. I have a question about the feet and the edges of the dish you are using. In the prime focus dish, we see the illumination on the edges of the dish at the level of 16 or 20 dB down from the center. Do you know the ideal level for an offset dish to the edges of the offset part?
In truth, I don't know. I'm making the same assumptions I make in illuminating a regular dish. In other words, you want to probably be someplace around 6 dB or more at the edges, maybe 10 dB. There's always this trade between how much noise you're going to pick up and how much gain you're going to lose. And today, I think you're better under illuminating your dish than over illuminating. You know, our receivers have gotten better and better and better. So you probably want to go to at least 10 dB at the edges with the type of receivers that we have today.
Any other question?
Have you already made QSOs
Oh yes, yes. Well,
with this configuration?
yes, but I was optimizing it. I was planning to be on for the 3 centimeter contest, the Dubas Aria contest, and you know, talk about stupidity. I decided to optimize the position. This is complicated. You have an angle, and you have you know, your feed point of the dish, and you got to get them both right. And I had 2 clamps holding the 3 centimeter system, and I was running sun noise measurements on it. So I'd run it, you know, into the shack, run back to the feed, move it, get it back on the sun, and I got lazy and I used 1 clamp. I said, oh, I got that clamp tight enough. You know, one of my rules that I don't follow, you know, when you get older, you're not supposed to make the same mistake, right? Very disappointing on that end, because I probably have done that before. And, you know, I tightened up the clamp, and the sun was quite high at the time, summertime, and my whole 10 gigahertz system on a plate fell 30 feet. I did get on though, and worked band. I got it back together, got the soldering iron out, and I have a hard time seeing here, but I worked Dan when he had his TK, the expedition, right before the Dubas contest. But the way I had it clobbered together, I was very disappointed by the signals I was getting with the system. But it was enough to work Dan's system using the digital type modes. I'm not anti-digital modes, but I do think that CW is another dimension, a very exciting dimension.
Okay, any other question about that? So no questions. Please take your position again and follow with your moderation. Thank you very much.
Okay, we have okay, we're almost on schedule. We're actually ahead of schedule, I think, which is terrific. It means we can have lots of questions and more time for talk. Right now, our next speaker is Merrick, who has done really great work, particularly on 3 centimeters. But now you're going, you know, this is the reverse. You went up to 3 centimeters, now you're going down in frequency. I don't know if I should say that's good or bad. Merrick has got a great signal on 3 centimeters, and you have a great signal now on 1296. Thanks.
So good morning, ladies and gentlemen, and let me briefly introduce my experimental EME work with small aperture antennas. Right at the beginning, I would like to say 2 things. The first, many of presented results will be achieved with stations which invested knowledge, time and money to construction of large antennas. And the same can be proud of. And second, CW QSO. However, I like also digivolts. Because a small antenna prepares digivolts, that is achieved again about 10 up to 14 dB compared to the CW. It is thanks to a very sophisticated signal processing. And because the signal processing on its microwave technology is belongs of my focus, that I like digivolts too. And the most fun are the cases that are in the physical limits of the signal energy balance. Most of my talk will be devoted to 10 gigahertz band, a little bit to 1.3 gigahertz band, that is for Minu, and finally I will mention the preparation of 24 gigahertz. Next one. Outline of my focus consists of these 7 points. First one, a bit of calculation. Second one, small offset dish and right feed. Third, focused antennas. Fourth, sun, moon and ground noise. Fifth, 3 cm EME operation with small dish. Sixth, 23 EME operation. And seventh, 1 centimeter preparation. Thank you. The loss of the direct electromagnetic wave propagation is in free space proportional to the square of the distance and inversely proportional to the square of the wavelengths. This means that at 10 gigahertz we have 20 dB more attenuation. Yeah. This means that at 10 gigahertz we have 20 dB more attenuation than at 1 gigahertz. The question is, are the microwaves therefore disqualified for long distance like EME communication? Next one, please. We all know they are not, because we are using the parabolic dishes, and gain of the parabolic dish is given by this equation. And is also inversely proportional to the lambda. And then are compensate the losses from one antenna. And we have 2 antennas. That means that in the results, the dish with same aperture has a gain of 20 dB greater than at 1 gigahertz, and the link is 20 dB favorable on 10 gigahertz. Next one, please. The choosing of type of the mirror, a small antenna, is relatively easy because the shielding effect of the feed is applied much more at a small antenna, and therefore the offset mirror is more advantageous. Spillover is also better eliminated, at least at low elevations. As a result, a lower antenna can achieve higher G to T ratio than the axisymmetrical antenna. Next. However, offset dishes are usually shallower, and the radiation angle of the feed needs to be adapted to this. For F to D 0.8, the central angle is about 70 degrees and should have a drop at the edges of aperture 10 up to 14 dB. The perimeter of the aperture is an ellipse with dimension W and H. H is higher than W, and that ellipse appears as a circle with a diameter W under the offset angle. That is why always specify W as the dimension of the offset antenna. Next one. I'm using Prodelin antennas with f to the 0.8. As a very good feed for 10 gigahertz band was shown original KU feed which are using for reasons. The center hole was enlarged to 22 millimeters and feed was pushed onto circular waveguide with inner diameter 20 millimeters. The picture shows a 3D radiation pattern of this feed on 10 gigahertz. Next one. Focusing of the offset antenna is somewhat more complicated as there are more degrees of freedom. While it's the axisymmetrical antenna, we move the feed along the axis, that means in one dimension. With an offset mirror, we need to know not only position in the space, but also correct inclination of the feed. The manufacturer therefore specified 4 distances for given feed, which define the position of the feed. For programming, it is better to rely the dimension in inches because they have a problem with conversion to millimeters.
Microphone.
So next one. I originally started with 1.8 axisymmetrical sheet metal dish, but even after trying hard, I could not achieve better aperture efficiency than 50%. I turned out that the accuracy of the mirror was at the frequency of 10 gigahertz not sufficient. That is quantified by Roux's equation as taught all about. Then I switched to the Prodelin 1134 1.2 diameter with mentioned feed, and the results were the same as the before used 1.8 axisymmetrical metal sheet antenna. So the achieved result corresponds to the calculated values by VK3 excellent calculator, and you can see that it was achieved sun noise to clear sky about 10 dB, and at the solar flux unit 90 and 0.54 dB for the moon noise to clear sky. When focusing the antenna, it is, after my experience, necessary to record the white range, we say 50-40 millimeters, and determine the focus from the obtained graphs by interpolation. Next one, please. This picture shows the moon brightness temperature. We can see that on 10 gigahertz, the brightness reference temperature is practically constant during all phases of the moon. That is big advantage. For 1.2 centimeters, you can see that it is much more fluxiano, and for 47 peaks, that is still much more. Next one. Finally, I changed the dish to the 1194 from Brodering, also with the same F2V and diameter 1.8 meter. And the achieved values, you can see, that means about 12 dB at 90 solar flux unit, and about 1 dB of the moon noise to the clear sky. Next one. Measuring the noise of the ground is worse. In order to be measurement comparable, we would need to ground in the far field zone of the antenna. And for 1 meter dish and 3 centimeter is far field zone far than 260 meters. That is problem, and only several of us have such condition. However, the radiometric scan of the surrounding can correspond to the terrain. Next one. What we lack in the antenna, we have to compensate otherwise. The question is how. I have 6 points which I think that is needed to thinking about. So first, G2T high as possible. Second, enough power. 3, frequency, accuracy and stability, including precise Doppler shift compensation ability. 4, precise automatic antenna pointing with continual monitoring of the moon noise and possibility to change plane of linear polarization. 5, advanced signal processing. 6, good planning. So, allow me to look on this point. G2T. In this picture, we can see a graph where parameter is TE. TE is a sum of temperature of sky, temperature of ground, and temperature of the moon. The system, equivalent system temperature, TS, is equal TE plus TRX, where TRX is the equivalent noise temperature of the own receiver. And if you see on the graph, here we have the noise figure on the horizontal axis, and parameter is TE, so we see that it's much important for small antenna to have low noise amplifier. But for bigger antenna, where the moon noise to the clear sky is about 3 dB, the better noise figure is not so important. Next one. Enough power. The minimum power for serious work on 3 centimeter band I see is 20 watts. I worked with such power for some time. Then I built 250 watts amplifier with gallium nitride module TGA 2312. Now from Volvo, before from of Charlie, G3WEG article in Google, and Charlie also helped me in its implementation. Thank you. After experience, 50 watt power is adequate for the reception capabilities of the well-adjusted system with 1.8 meter dish. Next one. Because with a small antenna we will work around CW of digimodes, the frequency precision must be better than 100 Hz on 10 GHz for serial sword. For this reason, the frequencies of the microwave transverters, but also IF, VHF, UHF transceivers need to be controlled by atomic oscillator, cesium or rubidium. For this reason, I originally used a self-made IF transverter with direct digital synthesizer located to the atomic normal. At present, I am very satisfied with FT991A, which has very high absolute frequency, accuracy and stability, better than 5 Hz on 2 meter intermediate frequency band, and allow Doppler correction with the step 2 Hz, what is advantage because the small step for Doppler shift compensation is an advantage, especially with small spread signals. Next one. Preferred method of Doppler shift compensation, as was mentioned yesterday at the workshop, is CFOM, constant frequency on the moon. This method allows to watch all participating stations on same frequency regardless their grid locators. The graph shows how WSJTX software works if transceiver is not able to change the frequency during transmission. That all transceivers often has this feature. I would like to point, next one. I would like to point out that in version 2.6 relays 1 and 2 of WSJT software, the echo mode is significantly improved thanks to Charlie's group, and measured values of signal to noise ratio and width are correspond to real values calculated even with large signal spread. You can see that here is spread 190 and the signal to noise ratio is really very real. Then the graph is the accumulated echo. Next one. Precise automatic antenna pointing that is clear for 1.8 meter dish is with the beam width about 1.2 degree is needed step not worse than 0.2 degree in both axes. And big advantage advantage is if you can watch the new noise immediately on the second receiver. Next one. U65 is the last mode of WSJTX which we are using, and that is really great, takes advantage of a priori information. But it is important to be able to use another features of this program as are longer transmitting and receiving period, as well as signal to noise ratio, use a reference spectrum which makes flat the audio channel of the receiver, and averaging. When averaging is used, it is very important to reset accumulation register at the right moment with the button clear averaging, so that there is nothing in this register than the message we want to average. Averaging improves signal to noise ratio proportionally to the square root of number of accumulation. That means if you accumulate 4 times the same message, the signal to noise ratio can be improved 2 times. That's theory. Next one. Good planning. Good planning is important in the QSO without budget margin. Small widths for both cold sky and low degradation. They are the parameters which we are looking for good planning. And also polarization matching, because on 3 cm we are using linear polarization. For some QSOs, they are on the limit, is needed to compensate the spatial angle by turn of the field, plus minus degrees. Dominic will talk about. Next one. I can say that with the current setup, I am able to work all I am able to work Digimodes with all stations that are working on the 10 GHz band. I was working with BK7MO many times, and also the Q team expedition, and the smallest one which I worked at was IK68K with 1.2 meter offset dish and 7 bar. Up to date I have 119 mixed initials and in 40 DX countries and 4 continents. And now, allow me, next one, a couple of words about 23 centimeters. I wanted to test whether it is possible to work with 1.2 meter dish also on 23 centimeters. Since I was just learning of analog device Adam Pluto module, software-defined transceiver, I modified this for 23 EME. Next one. This meant replacing PCXO for the better one with the stability 0.5 ppm, and also solved the PTT and stable power supply. Next one. Because Pluto is a broadband transceiver without any filters. That is broadband from 70 megahertz up to 60 megahertz. So that was needed to design and build the front ends for both channels. They are the front ends, and complete transceiver with analog with Pluto you can see on the picture. The feed was completed by low noise amplifier with noise figure about 0.35 dB and isolation relay. Next one. Some times ago, I designed for Zdeněk OK1DFC the arrangement of the second feed for a dish. Microphone. Sorry. Some times ago, I designed to the Zdeněk for the Zdeněk OK1DFC the arrangement of his septum feed for a dish F2D 0.8. It was reasonably based on the upper extension by horn. In the end, Zdeněk decided to feed to me, dedicated the feed to me, because in the meantime he had already started using a different dish. Next one. That is the block diagram of my setup. You can see the Pluto. Next boxes are the front ends, SSPA, LNA, isolation relay, and GPS do for synchronization. Next one. SDR console version 3, which Pluto supports, is used to control the transceiver. After a lot of experimentation, I used a pair of virtual audio cables to interface with WSJTX software. Both RX and TM transmitter frequencies controlled by WSJTX, and using a pair of virtual COM ports. Doppler shift compensation is comfortable with a step of 1 Hz. Next one. In 2 weeks, well-established 64 QSO with this setup for with 44 initials. In July, I lost borrowed SSPA, so I installed the exciter to the feed and tried extreme QRPP QSO. I managed to make 10 QSO with 30 watt and this small antenna. And July, I tried also reset the transmission of PAC KAM SSTV, which was managed to the 53rd anniversary of Apollo 11. That was great fun. Thank you, cameras group. Next one. And finally, 24 gigs. I am finished transverter, homemade transverter with homemade LNA. LNA is with 1 dB noise figure, and I designed and Zdeněk implemented implemented also the feeds for F2D 0.8 and also 0.6. So I hope will be QRV in the near future. Thank you for your attention.
Very informative. Thank you. We're ready for questions? Okay, let me see. You want to run with the mic or?
Question?
Yes. But, okay. Video.
Thank you, Mary. Can you explain why you need to be in the far field of the antenna when you're measuring ground noise? I guess that that would not be a point source, or rather a distributed source.
Yes, but if it may be comparable with the measuring of other sources in the far field zone, that also ground needs to be in far field zone. That is the reason.
Okay, but you're looking at temperature, and as long as the source you're looking at fully fills
Yes.
temperature, then it should be, you just see temperature.
Yes, I agree, but if the value of the ground can be comparable with other sources which are in the sky, that for my meaning it is needed to be in far zone. And if you put the antenna to the ground and you have ground 5 meters, that is not the situation which is comparable, after my meaning.
Thank you.
Yeah. Charlie? You also can have a problem with Bisbar, the reflection if you get too close to the,
Yeah, okay, but if you were 100 meters away or,
right.
or 50 meters away.
2 or 3 meters away.
Yeah. Yeah. 50 kilometers.
Nurek, thank you for a very interesting talk. One observation for both from Al's talk and yours is, I don't know if you can, from the shack, switch your isolation relay independently of the transmit-receive. I've just started doing that. I know many stations do this as routine, but it seems to be a very good benefit in being able to just switch the preamp,
Yes.
to 50 ohms when you're pointing at the sky. I'm finding with the new dish interesting differences between ground noise as a function of elevation, but I can only reference that to the 50 ohm load. So it seems very useful to be able to always from the shack have a button to switch the preamp to 50 ohm and look at your ground or your sky to 50 ohm reference rather than ground reference. And also you can do sun noise measurements relative to the 50 ohm load. And that of course can change with temperature, but it seems a useful test facility to be able to always have the preamp. I had to add a relay simply to the TR system so that when I pushed it, it didn't put the PA on. But that was the only small modification, but it was quick to do, and it does seem an interesting way of keeping track of noise. So, sorry, it wasn't a question, but it was just to add a comment that switching 50 ohms is useful.
Yes. No problem. That's very interesting because I was in the same test with my 4-port switch, waveguide switch.
I'd like to comment on that because that's great as a relative reference, but there's a problem with switching to a 50 ohm load versus to the antenna, and that is that the impedance of the antenna can be different than the 50 ohm load. And a lot of amplifiers, low noise amplifiers, particularly maybe worse at lower frequencies than the microwave frequency, but their gain changes. And so It's not noise figure that you see the change in gain of the amplifier. That changes the noise you see. Now, you're using that same reference all the time, that's fine as a relative, but it doesn't give you an absolute measurement. And a lot of people think that the 50 ohm load is an absolute measurement compared to the antenna. So you can get around that by doing accurate gain measurements and making sure that the gain differences and it doesn't change significantly, but in a lot of cases the gain does change significantly.
We have a lot of experience with that, with Lada from OK1 Kilo India Radio on a 24 gigs, where we were testing the new LNAs for low noise LNAs. So.
That's the trouble. Feeder should have one dot. Trouble is matching feed itself and the LNA itself as well. But what we are doing, looking for noise figure of LNA, we are measuring on 50 ohm, so we are establishing and tuning everything on 50 ohm load. So if I put the 50 ohm load, must be precise, of course, it's okay, everything. So trouble is in the field of the antenna. Or the reflection, that's we talk about it. So it's a bit tricky, but I can recommend what Charlie said. Everything what we have, separate relay, which is RNA from the peak to the low, peak low. In any time, immediately I know if something we can drop or happen, or especially interference with the state. What we suffer from the state, Wi-Fi and so on.
This is absolutely true. I can tell you that I am using between LNA and transverter on 24 and also on 3 centimeters. I'm using the filter. Very, very sharp filter. And if you don't have a good isolator, circulator, call it how you want, on the output of LNA, you are out of the order. Because a lot of the reflection is coming back from the filter, I mean from the frequency range of the filter, which is not the pass exactly for the frequency, and that is especially on the 24 gigs we had a lot of the problems. Even we were using the perfect military products, isolators and so on. Okay, any other question or comments on that? Yeah. Okay. Don't worry.
Yes, thank you, Zdenek. Well, I found it a very interesting point that about having the 50 ohm switching to the relay. But I have been doing a lot of measurements on relays and on these 50 ohm resistors. And there is a lot of rubbish around, so before you do that, do some very tough measurements. Because there's really 50 ohm loads which are above 2 gigahertz are rubbish. Thank you.
Yes.
That's true.
That is standard radiometric method. Yes.
Yeah. By the way, guys, it's a little bit out of, but I have a question for you, because in a company we had a training about the European standards. Do you know what the CE means? China export, exactly. Okay, guys, we have now the coffee break. Please take a coffee, relax a little bit, and we will follow exactly at 11. It means after the 30 minutes. If you will finish the coffee early, please go back and we will follow. The coffee is there. Thank you, thanks.